Well, if you are on time, thank you so much for joining. And in case you are watching the video, the recording, then I suggest that you skip off the first minute or so because I will wait a little bit for people to join. Uh, the yesterday's response was excellent. I enjoyed spending time with you. Kevin Jacob, Bhavya Sharma, Navnoor Kaur, Pratyusha, Abhilash, Pragati, Mridul. Good afternoon, everyone. So good to see you on time. So good. Uh, so many more. Deepak Rajput, Arnava, Mridul Sharma, Sana Srivastav, Visalakshi Chiller, Anvita. So to begin with, I will respond to your good afternoons, but then later on, I will ignore these good afternoons. I hope you don't mind. If you are on time, we wish each other. Otherwise, you come and you join the class. Shiven Agarwal, Parth Sharma, Sapna Pujari. Good afternoon. So yesterday we started talking about something called Aniket 2020, Ansh Bhatia, Madhu Vardhan, Deepak Karal. Good afternoon. And now no more good afternoons. Acha chalo, Pratham Gupta and Nishika Goyal, good afternoon. Uh, so that's it. No more good afternoons now. Uh, those who come, kindly join, welcome, but then we'll continue with the class now. So yesterday we talked about a concept which is called net external force. And before we revise that, I will quickly take you through those formalities of telling you where we are having this course and all that. I will answer as many questions as possible during the class. But if you want to discuss things further, you can join my physics group on Telegram, details of which are on the first 2 pages of the course, the online course which we are following on anytimeteacher.com. I'll give you that detail also. Hi Aaron, love you. Uh, this course is activity based and discussion based, and towards the end of this course I will discuss previous year's questions from medical and engineering entrance also, but we will concentrate more on developing our thinking, developing our interest. We will concentrate more on that, but I will end the course with the previous year's questions of medical and engineering entrance. I said those who join late, I won't respond to good afternoons, but welcome. So this is how to join the course, but then kindly note, I am about to change that course because somehow I am not very much convinced that I have to keep it as per NCERT. I will have to change that course, but then this is where the course is. On anytimeteacher.com, there is a menu, main menu, academic courses for MCS. There you find 11th physics, and in that you click on laws of motion and then click on that button, take this course, which is next to that green colored free. There will be self-assessing quizzes on every page. I will be updating this course. You are also fresh to 11th, and I will change this course in due time. And these ways of reaching out to me, they are available on the first 2 pages of the course itself. So you need not copy anything from here. So yesterday we rephrased the first law, little bit rephrasing. We neither can and nor intend to change, just rephrasing, that a body at rest, if it is kept, means it is at rest. And we had this body and it was kept on some books. It was kept, and it will remain at rest. If there is no net external force, it will remain at rest. And then the problem started. I said, even if I apply some force here, see, you can see that this string is getting tight. I'll put it like this. You can see the string getting a little bit tight. But the body at rest remained at rest even though an external force was applied on it. And somebody said that it is not external force, it is some unbalanced external force. And yes, very right. The technical correct word is net external force. Net external force. But then there were certain questions and certain points which were raised regarding friction. And some of you said that friction is more than what I am applying. Friction is more than what I am applying, and so it is not able to move. I said we will keep this course to begin with just based on your common sense. We will keep this course, we'll avoid doing high level of mathematics. We will avoid it initially, we will just keep it to common sense. Now come back to that common sense wala point and let's have an answer to that comment which was put up, that somebody saying, somebody, not just somebody, many of you believe that, and in 22 years I have seen hundreds of people believing that. They say friction is more than the force that you have applied. Friction is more than the force that I have applied. So the force that I have applied, let me call it P. They say this P is less than the friction. I'm saying let's talk common sense. If friction is more than P, let me give you some numbers. Let's say my P, the force that I apply, is 5 Newton and friction is more than that. So give me a number which is more than 5. Let's say it is 7 Newton. Friction is 7 and the force I am applying is 5. What do you expect the body to do? Should I draw it? Should I draw it? Let me draw this thing and take you to this discussion further. Say this. Just a second. Just give me a moment, please. You know, technology needs a little bit, but I will be able to do that. So this is the situation. The P that I am applying is say 5 Newton. The body will remain at rest. Jesus Singh. Good question. Aditya says the body will move in opposite direction to applied force. Yeah, let's see. So the force that I am applying is, kindly note those who have joined late or those who were not there yesterday, this is a discussion. This is not finishing the syllabus. We are not finishing the curriculum. This is a discussion. We want to get interested in learning physics. We do not want physics to become a set of formulas, set of rules. This is just to understand the world around us. Okay, and so we are keeping this course, to begin with, we are keeping this course centralized around common sense. I said, before I end this course, I will certainly do with you previous year's questions from medical entrance and engineering entrance, but by that time your minds would have grown that much that you will be able to answer the questions automatically. Okay, so this is the block that I'm having, this block, and the force that I'm applying is 5 Newton, and somebody said this friction is more than P. So I'm saying let this F is 7 Newton. Because you understood Newton even yesterday, so I'm using the term. Because you said you understand this term Newton, so I'm using it. But if this is the case, a body should... Bhavya Sharma, that's it. See, if this is 5 Newton and this is 7 Newton, in which direction? See, this is my right. We decided it yesterday. This is my left. So, which direction do you expect the body to move? Remember, common sense. Use common sense. This side, there is one thing. If I try to pull it with 5 Newton, I just hope that I set it up properly. You are able to see this body. If I try to pull it by 5 Newton, do you think that this body can ever go back? Do you think ever it is possible that I'm trying to pull it? See, either I will be able to pull it, like say, now I have been able to pull it, or I will not be able to pull it. But do you think it is even sensible that I try to pull it and I'm not able to pull it, and somebody says it is going to move like this? Do you think it is even possible? So many people say, no, 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 Pratyusha saying, but sir, isn't friction basically caused by irregular? That is okay, that is okay. Surface is straight, so no movement left. Do you see that? So it means those and all those who said friction is more than P, that doesn't make sense. Do you agree with me? All those who said the body is not moving because friction is more than P, or the other way around, P is less than the friction, they were not talking sense. Because if that is so, then while I'm trying to pull this block, and if I'm not able to pull this block goes back, which is nonsense, which doesn't make any sense at all. It doesn't require you to have studied physics in 11th or done some engineering course to answer this question. Do you get this? Have I been able to answer that part? So coming back to where we were yesterday, that uh, the correct word is there should be a net force, and some 2-3 of you use the word unbalanced force. If there is an unbalanced force, the body will move. Out of that, what came out as a misconception, I have explained that, tried to explain that. Then this net force, we took few examples yesterday that in certain cases, you can answer how much is the net force just by common sense. You don't need to study vectors. You can answer those questions just by common sense. And some of the answers that you gave yesterday, I can why is this pen behaving in such a funny manner? So we took this example yesterday. Let's say this side it is say 5 Newton, and say this side it is say 2 Newton. You could make out which side will the block move, this 5 Newton or 2 Newton, right or left. And you answered correctly yesterday that 5 Newton it will move towards the right. Out of the two cases, if I say, see, there is another case. And all this is common sense. And when you answer correctly, I really feel very happy. It means you were born intelligent. And like Einstein, remember, I said, I don't know whether it is really Einstein or not. Let's say this is 4 Newton. This is case 1. This is case 1 and this is case 2. In which case will this block move towards right? In which case will this block move towards right? Let me wait for few comments. No, you are saying right, right, right. I am saying out of 1 and 2, in which case will it move right? Case 1 or case 2? See, you are born intelligent. Do you believe when I say everybody giving a correct answer? In both the cases, it moves right. Now, my second question. In which case it moves faster towards right? Yeah, very good. Excellent. Excellent. Top class. See, पैदा इंटेलिजेंट जो बच्चे हुए होते हैं वैसी जवाब दे इन बोथ केसेस इन बोथ केसेस बोथ केसेस बोथ केसेस ओके नाउ माय सेकंड क्वेश्चन in which of these two cases it will move faster towards right? Case 1 or case 2? In both the cases, I'm saying no. This is not a googly. Last question was a googly. When I said in which case it will move right, it was not in which case, both the cases. And you caught it right. Now come to my second question, and this time you have to pick up one of the two. Out of 1 and 2, in which case will it move faster towards the right? Do you see, these kind of things, they don't need much, you don't require to go to a college to answer these kind of things. So you know that here. Now, how are you able to give this answer? How are you able to give this answer? You saw this thing 5 here. You saw this 5 here. And you saw the left side it was 2. And here it is 5. But then left side it is, here it is 5. But then left side it is 4. And you correctly concluded. So what you have done is that net force in this case is 5 towards right, minus 2 towards left, and so there is a net of 3 which is net and towards right. Isn't that your thinking? Isn't that, might be you are not aware that you thought so much, but isn't that your thinking? That's where you call common sense. Madhavi Yadav, Yeah, that's where we use the word common sense, that this much we are born with, this much of intelligence. But see, if you try to give words to your common sense, if you try to give words to your thinking, then this is what your thinking was: 5 towards right, 2 towards the left. So there was a net of 3 Newton towards right. But in this case, the net force is 5 towards right minus 4 towards the left. So you had 1 Newton net force towards right. And that's how you were able to conclude and correctly conclude that which one was more. We saw another case also yesterday in which two forces were acting at 90 degrees. Right and up, we drew a diagram, and even in that, you were able to correctly tell few things. Say, for example, the forces were something like, say, 3 Newton. I don't remember exactly the numbers that I took, and say 5 this side. And this much you could conclude, that even if you draw a line, central line, this body will move somewhere here. Somewhere here it will move, somewhere in this region it will move. That much you were able to conclude just by common sense. When you study this topic, vector, you will be northeast, Deepak and Shikha. Northeast is actually a center line. North, see, this is north and this is east. And when you say northeast without anything else, then it means the center line 45 degree. It's not that whole region between north and east. Okay, Vijalakshmi? Between north and east, yeah. Better word, between north and east. But even in that, this much you could conclude, that because this one is more, so it is somewhere here, somewhere here. But then if you study this topic, you will be able to tell exactly the angle. That's where math come in between. That's where math comes in physics. मानस गोयल, अच्छा मानस गोयल पढ़े लिखे आदमी हो. Okay, yeah, that tangent theta is 3 by 5. Where is that theta and all those kind of things? But then your answer shows that you know the answer. You understand this thing. But see, that's where math comes in. Math is okay, Ritesh. Uh, Math is the language of physics. If you know math, you talk precisely. You give answers in exact numbers, and you don't just give roundabout answers, nearly answers. You give exact answers. That's where vector comes in between. And someday during the class, I will teach you this thing, and I will try my best that you don't even realize that I have taught you this, because it is that much simple. It is actually that much simple. So somewhere in between, I'll teach you all these vectors. You have not realized that just now I taught you right and left and you did the subtraction, because that's all that it is actually that much of common sense. So I'll move ahead right now. This one we are not doing because this is the actual question. This presentation we use for teaching pre-medical, pre-engineering, those kind of classes. So not everything on this presentation is for you. Okay, so let's take this discussion ahead and conclude few things. If speed or the direction, any of these things, it changes, then there is definitely a net external force. So consider something which was at rest, its speed was 0. Something which is kept, which is at rest, its speed is 0. And suppose it starts moving. A body at rest has started moving. So its speed has changed. Its speed has changed. Are you getting? Body which was kept at rest, if it starts moving, its speed has changed. And something which is moving. So I have a lot of things here, lot of balls, lot of things here, say something, and I'll show you some of those things. If it was, say, ball was rolling and it changes in direction, so whether the speed changes or its direction changes, there is a net force. We will see the converse, inverse, everything. But before that, let me ask you a few questions. Get on to what is the syllabus of these questions. Either speed changes or the direction changes, certainly there is a net external force. And before moving ahead, let me ask you some questions based on this part. Let's say there is only speed changes. Osama bin Laden पहले बॉम्ब लगाया, उसके बाद में बॉम्ब फोड़ दिया. ऐसा काम क्यों करते हो भाई? ध्यान दे लो. क्या पता कुछ इंटरेस्टिंग लगने लग जाए, समझ में आने लग जाए, तो क्या पता चॉइसेस लाइफ की बदल जाए. इधर ध्यान दे लो बेटा. So let's say only the speed changes, only the speed changes, only the speed changes. Now in these two cases, tell me what is the angle between speed and force. If the speed increases, speed changes, and what I'm doing is case A, speed increases. Can you tell me something about the direction of applied force? Ritesh, listen to me clearly once again. Speed changes and I have made A and B. A, speed increases. Okay. Look, listen to the question carefully. Good, very good. The speed changes, but case A, I'm saying speed increases. Say it was moving with 5 meter per second, now it is moving with 8 meter per second. Only speed has changed, no direction change. Direction of the movement of the object. Okay. So all these people, Shikha Kotwal, Arnava, Verma, Swapnil Kumar, Visa Lakshmi, coronavirus, all those people, Sana, Pratyusha, all of you are giving correct answer. See, you have never been to 11th and you are giving correct answers. And by the way, laws of motion is not the first topic of class 11th. By the way, the first topic is all those kind of things, units, dimensions, then kinematics and motion in one plane, one dimension, two dimension, relative velocity, and then you come to laws of motion. You have never been to class 11th. This is not the first topic of class 11th, but your answers are correct. And that's what my desire to get in touch with you was. That let me show it to you. How much common sense were you born with? Ritesh Wadhwani, these are not. But then you see, if you maintain this kind of thing, that I understand what is being talked about, and I have that natural intelligence to answer questions based on that, you will find you will be able to handle physics very, very well. And I can assure you, before the course ends, when we are doing those questions from previous years, medical entrance, engineering entrance, you will be able to handle those questions in a very effective manner. Now let's come to the second part. Only the speed changes, but we saw speed decreases. What is the angle between the movement, the velocity, and the force that is being applied? Say something moving with 5 meter per second, something moving with 5 meter per second, it starts moving with the 2 meter per second. Only the speed changes. Boti boy, lungi dance, karo, खूब करो. अभी तो छुट्टियां हैं, खूब डांस करो. अरे कोई दिक्कत नहीं है, कोई दिक्कत नहीं. छुट्टियां हैं, क्लास भी मजे वाली ही चल रही है. लुंगी डांस करो, टावल डांस करो, बेडशीट डांस करो, टी शर्ट डांस करो, सारे डांस करो. हाँ, okay, please. That's okay. Very good. So, absolutely no issue. Brilliant. Let me pause for a second or two to see more people answering, because so many people have answered and you have answered it correct. 180 degrees, you means opposite, है ना? Let's say something was moving in this direction with 5 meter per second. So what you are saying is 180 degree. Now let me ask you more. Suppose the speed remains change only, है ना? So I am saying speed remains same. Speed remains same. Only the direction changes. Can you say something about the direction of force? Something about the direction of force. Let me show it to you. Let me see if I can show it to you. But before I show it to you, let me get some answers. Okay, Manas Goyal, as usual. But kindly note, everybody is giving sensible answers. Okay, Manas Goel, Kriti Rao. Okay, then let me show it to you. I was expecting more answers, and see, more are coming. Labham Jan, one more live stream today. This I'm not able to understand. Labham, what are you asking for? Wow, acha, oh, so I was right. When I said I was expecting more correct answers, there are more correct answers. So there is a slight delay in the stream. So when I say something and it comes few seconds later. So I'm able to see your comments few seconds later. Okay, so let me show it to you. What kind of motion is that? You see the speed. See the uh-uh. Oh, just a second. After that, this thread gets twisted a lot. So what is happening is this thread is tight. So you can't say there is no force. Let me unwrap this thread. Okay. See, if this thread is tight, then this thread is applying force. If this thread is tight, we call it tension in the thread. So if this thread is tight, there is tension in the thread. And tension in the thread means it is applying some force. So this thread is applying some force on this bob, this metal ball, but its speed is not changing. This you studied in, I think, class 9th, you must have studied that in circular motion, the force which is applied on the body is a 90-degree perpendicular to the motion. There is a point in saying, instead of using the word velocity, using the two words separate, speed plus direction, there is a sense in using that. Because when you say velocity changes, the speed, अच्छा स्वप्निल को टेंशन बहुत ज्यादा हो रहा है डायरेक्शन ऑफ फोर्स इज चेंजिंग हाँ yes very right okay now when you say velocity changes it has hidden in it two parts the speed could have changed the direction could have changed both of them could have changed so when you say velocity it hides that information so there is a sense when you are talking of numerical problems there is a sense of talking two words separately calling speed and direction separately. Okay, so now let me move on to the next case. If neither the speed has changed and nor the direction has changed, speed has not changed, direction is also not changed. For example, a car is moving on a straight road with a constant speed, or another thing, a body at rest remains at rest. Remember, that's how we rephrase the first law. A body in motion remains in straight direction, neither the direction has changed and moves with constant speed, nor the speed has changed, or a body at rest has remained at rest. Then, even if there are forces acting on the body, their resultant net is zero. Their net is zero. Means it is a misconcept to say that there is no force acting on the body. See, when a car is moving with constant speed on a road, can you guess constant speed? Car moving with constant speed, let's say 60 km per hour, it is moving on a straight road and continues to move with 60 km per hour. Can you guess forces acting on it? Or you say there is no force acting on it? A car is moving on a straight road. Very good word, very good, very good. इसका मतलब तुम बात को पकड़ने लग गए हो. Force not acting on it, that term is wrong. You say net force is not acting on it. Very good. See, Manas Goyal saying weight is there. See, then any other force. The road is not getting pressed. So the road is applying some kind of force upward. Otherwise, the vehicle would have gone down into some kind of pit kind of thing. That road is holding the vehicle from going down. So weight is there, but then due to the weight, the car doesn't goes down. It continues to move straight. So it means the road is holding. Imagine this car going over some leaves, some pit which is filled with leaves, dry leaves, what will happen? The gravity will pull it down. Who used this word normal force? Mayank and Aniket. Impressive. Manas Goel, normal, impressive. So it means you even have the knowledge also. So listen to what I'm saying again. This car going straight, suppose there is a pit in front of it, there is a gadda, and it is filled with leaves, and the driver doesn't realize. What do you expect will happen? The vehicle will go down. Why? Gravity pulled it down. So why was that car not going down when it was on the road? Are you getting my question? Are you getting my question? On the road, the gravity was acting on it, but the car was not going down. When it came to a pit, the car started going down. Let me do it for you so that you start understanding it better. I hope I set up the angle correct because there is a delay. So say this is a body which is moving on a road straight like this thing, and then it comes to a gadda and it goes down. Right? So why does it go down here? Why does it go down here? See, once it goes here, it goes down. Why? Due to gravity. Then was the gravity not acting here? Then why did it not go down here? It means this book is applying a force in the upward direction. This book is applying a force in the upward direction. And because now you see this block is neither going down nor going up, it means the gravity and the force that this book applies upward, this surface applied upward, they must be equal. ओसामा बिन लादेन साहब ने तो बजा दिया, 1 2 3 4 5 6 7 8 8 ब्लास्ट कर दिए हैं ओसामा बिन लादेन साहब ने. Getting it? Are you getting it now? ओसामा बिन लादेन, इसके अलावा भी इंटरेस्ट दे लो, बहुत बॉम्ब फोड़ ली है तुमने आज. इसके the road is a solid surface while the pit would have air spaces between the leaf. Okay, balance out. In the pit there was no interface for normal. Okay, coronavirus bang bang को रखा है. Have I been able to put a question into your mind? See, gradually you are getting introduced to forces that acts on a body and in question. You will find that this force which the book was applying, in the example of the car, the force that the road was applying upward, that is called normal reaction or normal force. Normal reaction, normal force. Very common word in laws of motion. And you have seen that there must be something like that in the upward direction. Otherwise, the body will go down. Okay. So we continue this discussion tomorrow, but before we close, because I want to keep classes with you very short so that you don't get bored. Ultimately, say you have passed your class 10th. Only freedom that I have taken is because your coaching classes are also not running. अरे मेहुल लग जा गले क्या बोला. Thank you so much बेटा, thank you so much. So no, the session has not ended. I'm keeping it short because you should not get too bored. It should not become too heavy for you. अच्छा, अद्रियान से क्या कहाँ बोर हुए हैं सर ना? Okay. अच्छा, Shikha, thank you so much. Ritesh, thank you so much. Okay, so what I'll do is I'll close with one more case, that if net external force is not equal to 0. If net external force is not equal to 0, अच्छा, nephew, Madhavi Yadav, nephew. अच्छा, Aryan, thank you so much. मोदी जी नमस्ते भाइयों और बहनों. हाँ, अच्छा, Ritvik says we are already bored. Pratyusha Kumar, please continue, sir. What book should we refer? Acha, books wala, I will answer and I will close. Certainly, I don't want to bore you. That the choice of books depends upon what is your target. Why are you studying physics in 11th? If you are that I'll take later on. Choice of your book, which book you should study, depends on what is your target. So, in general, if you are targeting things like pre-medical or engineering entrance kind of thing, a book by H.C. Verma and a book by D.C. Pandey, they are good enough. But then don't run around to so many books. The material which your coaching institutes give, they are in general very good material, but then stick with the material. Most of the books that you will find here, they are say this is DC Pandey, this is previous year's questions, that kind of thing. So you will find HC Verma. HC Verma sir is my guru. So HC Verma, so you will anyway find. I have been using HC Verma for 20 years now. Thank you so much, Aaron. So your choice of books, but then most commonly that say questions are very good in HC Verma. The only negative part with H.C. Verma book is the language is intentionally kept very general so that you get confused in understanding did he mean this or did he mean this. So you have to discuss both the or all the possibilities which are there in that language. That is the only negative part, but questions are extremely good, extremely good. And DC Pandewala book is written with a lot of hard work. I really appreciate these two people and their books. So in case you are targeting these entrance exams, these two books are sufficient. Other than that, your coaching institute will give you some material. Don't run after too many books because you will not be able to do them. There is so much to do, so much to understand. I would suggest that instead of spending, say, running after too many books, you start doing some of the basic kind of activities. Something that you try doing it with your hand. You see around so many, all these things that you see, balloons, some metal foils around a ball, all these kind of things lying here. Because with class 12, we were doing these activities. So thank you so much. See you tomorrow at 2 o'clock. Tomorrow at 2 o'clock. As ebooks, Aaron Chan, I don't think that is, say, allowed kind of thing. Because getting ebook might not be a fair trade practice kind of thing. But then they are available. Truth is, they are available. Okay, then see you tomorrow, 2 o'clock, for a short session. We'll continue with it. Okay, bye bye. And continue discussing in the Telegram group that you have, most of you have joined. Thank you so much.